Rightio. So yeah, this is the super speedy explanation on how to do trig. Okay, we're talking right angle triangles, and we're talking how to use sine, cos, and tan. All right. So I had recorded the audio on my OneNote explanation for this, but it means those of you with Macs that can't view it or hear it properly, you can watch it on YouTube instead. Okay, so we've got these friends called sine, cos, and tan. We can use them to help us figure out how long a side is or how large an angle is on any right angle triangle, provided that we've already got two other bits of information. Okay, with Pythagoras, we were only dealing with sides, and that was great. We knew two sides, so therefore we could figure out what that third one was. With trigonometry, we're now talking about an angle. Okay, in this case, we tend to call it theta. We tend to denote it with that lovely little theta sign. Okay, so we need to label our triangle with trigonometry. Okay, that's the first step, is we're going to label our sides. The labels that we give them are O, A, and H. O, A, and H stand for opposite, adjacent, and hypotenuse. The hypotenuse, he's sweet and easy. He's just like the Pythagoras, it's the longest side. But the opposite and adjacent, that is with respect to the angle. So O is opposite the angle. It's at the opposite end of the triangle. Okay, its length isn't touching the angle at all. A is adjacent, so he's right beside the angle. Okay, that's what that word adjacent means. If I'm sitting adjacent to someone, then I'm right beside them. So that's the first step, is labeling those sides with respect to the angle that we're talking about. And it could be that it's an angle that we've been told how big it is, or it could be an angle that we're going to be trying to find out. Doesn't matter. This labeling is still the same. So first of all, you label them O, A, and H. Now you're going to have a look at those labels that you've done and have a look and go, okay, which two sides do I care about? Which side do I not care about? So if we look at this example here, I was given a triangle. Let's say you've got one and you've been told that it's 40 degrees in there. You know this length here is 4 centimeters, and you want to know how long the hypotenuse is. Okay, so in this case, you're going to label those sides to start with. So we've got O, A, and H. Okay, with that one there, that 4 centimeters, he's opposite the angle. Then we've got A for adjacent, and then we've got our hypotenuse, which in this case is X. Which side don't we care about? We don't know what it is, and we don't want to know what it is. So let's get rid of it. You can sod off. There we go. That's the A, so cross them off. We don't care about them. O and H, those are what we do care about. So we're going to use that O and H and think about this little cutesy-weetsy term called SOHCAHTOA. And this is used in countries throughout the world. It helps us remember whether or not we're going to use sine, cos, or tan. Okay, so the S, the C, and the T stand for sine, cos, and tan. The O's, the A's, and the H's that you come across in here are those sides that we label. So in this particular example that we had here, and I'll just start zooming out a bit, it was O and H that we care about. So is the one that uses O and H. So we're going to be using sine, because the S is for sine. All right, so now we're going to substitute those values of O and H and the angle into the equation sine angle equals O divided by H, okay, or O over H, the fraction. For cos, it's cos of the angle equals A over H, and for tan, it's tan of the angle equals O over A. All right, so substitute values in, and then we're going to just do a little bit of rearranging. So for this one here, we're going to substitute our values in. We end up with sine of 40, so sine of theta equals O over H. Sine, the theta is, the angle is 40 degrees, so we're going to put 40 in there. Our opposite is 4, and our hypotenuse we don't know, so that's X in this case. And then we're going to do a bit of rearranging. So sine 40 you can do straight on your calculator, okay? You literally just type in sin with the button there, okay? Sin, and then type in 40. You'll notice that it opens up a bracket for you. As soon as I typed in sine, it opened up a bracket. So you might want to close that bracket as well. For these questions, it doesn't matter so much, but it's a wise idea to it's just reminding us that we're doing the sine only of that number 40, no other little plus 4s or anything like that on the end. Okay, and then push equals. And so for this sine 40 equals 0.64, okay? We don't necessarily want to jump to that. We don't necessarily need to work out what sine of 40 is, because we want to keep rearranging if we can. So for this example here, what you do is you rearrange your equation by timesing by x on both sides and then dividing by sine 40. And you'll start to get used to these. What you're actually just doing is swapping the x and the sine 40 around. Okay, you're just swapping their positions. Because it was originally sine 40 and x, you're just going to swap them over. So on your calculator, you can now do 4 divided by sine 40. Okay, so just literally you can type it in, 4 divided by sine 40, and that'll give you 6.22. As always, you'll check your answer makes sense. What's it telling us? Oh, that's right. We were working out the length of a side. It was the hypotenuse we were working out. So this answer we've got had better be longer than my other side, A, because it's a hypotenuse. So sounds pretty sensible, 6.22. It's not stupidly longer than 4. It's not like 1,000 or something. It's pretty close, and it is a little bit bigger. And of course, we're centimetres, and you've written down any rounding that you've done. Okay, let's have a quick look at another example. Let's say I've got one here. It's a right-angled triangle. I am told that this angle here is 60 degrees. I want to know how long this length over there is. Okay, that x. So first step, you label your sides. Adjacent 10 meters is the adjacent side. Our x is the opposite side. And we've got our hypotenuse. Don't give a stuff about the hypotenuse, so cross them out. Okay, you've labelled them. We're left with O and A. That's toa and SOHCAHTOA, so that's tan. All right, chuck your numbers in. Tan 60 equals x over 10, because this time our O is our x, so that's on the top this time. Okay, just noticing that. For our first example, our x was on the bottom. And these are the two different ways that we can come across these. Either your unknown is on the bottom of that fraction or on the top. And then to get rid of that dividing by 10, you're just going to multiply by 10 on both sides. So we end up with tan 60 times 10. Chuck it in your calculator, you're left with 17.32. A reminder as well, just make sure that your calculator has the little d up the top for degrees mode. You don't want to be in radians or gradians for this, okay? So make sure you've got a tiny little d up the top. If you don't, you just need to clear your mode. So on most calculators, it's sort of shift mode, and then I think 3, and then equals. Alrighty-o. Let's look now at trying to find an angle. So those first two examples was trying to figure out how long one of the sides is. This one here is figuring out how large one of the angles is. So we've been given a triangle here. We're told that the hypotenuse is 2 meters long. We don't know this angle here. Okay, could be anything. Let's say it's a skateboard ramp, okay, or a wheelchair ramp that's entering a building. And then we've got 1.2 meters going along there. That's a really poor looking one. Okay. So first step, label them. Okay, same as before. We've got a hypotenuse going on. We've got this is adjacent to the angle and opposite. Just realizing I've been using, oh no, I haven't been using the same corner. Cool. All right, so you've labeled them. Cross off the one you don't care about. Don't care about the O in this case. We're left with the A and the H. SOHCAHTOA. Ka, C-A-H, so it must be cos. So we pop in all the bits and pieces that we know into cos theta equals A over H. In this case, A is 1.2, H is 2, so we've got 1.2 divided by 2. So we have got this guy here, and of course that makes 0.6. How are we going to now undo the cos part? It's not cos times theta. Okay, it's not cos times an angle. Cos doesn't exist on its own. It's not a number as such. It is this ratio of A over H. So to undo cos, we're going to do inverse cos, okay, which is cos to the power of -1, okay, or 1 over cos. That is how we undo cos, okay. We'll get rid of it. So on your calculator, you would do shift cos. You'll see the little cos to the power of -1 written up above the cos button there. Shift cos 0.6 equals. Okay, you're going to get a lovely number. You're thinking about degrees, so you know you've got to make sure you're going to be in a triangle, so it's going to be less than 90. It's a right angle triangle, of course, so it's going to be less than 90, somewhere between 0 and 90. Check your answer, make sure it makes sense. And because it's degrees, make sure you put your little degree sign in and any rounding. Speed version. Hope that helped. All right, let me know. Just email me if you've got any questions at all, guys. Cheers.